dimensional analysis. And yes, I'm telling you again and again, other than NCERT, it is very important that you read integrated book also for this chapter. Definitely you read that, because there will be much more things and more examples also will be there. If you want to solve the questions, I cannot even recommend you to solve the questions from HC Verma. There are not many questions in those books also. So I highly recommend that if you want to solve many questions, then integrated book is very good. In that there are plenty of questions. You can have practice from that. Okay. Application of dimension analysis.
Okay, sir.
Number one is to check consistency of dimensional consistency. We can say whether the equation is dimensionally consistent or not, and if it is consistent dimensionally, then only it will be correct, otherwise it will be definitely wrong only. It has to be first dimensionally consistent, else it will be wrong equation. That is one thing. Number two, I will not elaborate on it, already I explained in the morning. Okay, one quick example I can take. A plus B sine D by C, this thing, or maybe C raised to power A B is equal to, let us say, X, where X is, let it be e raised over this thing, where X is having dimensions of length. Find out the dimensions of A, B, D. Wait a second, I think I did already something wrong here. I should have taken AC plus BC. Now find out the dimensions of A, B, C, D. Find out the dimensions. Although this question is not related to the heading here, heading I have given to check dimensional consistency, it is not related to that, but we are actually finding out the dimensions of some unknown equation. We don't know what A, B, C, etc. means. Only one information is just given, and that is enough to get the dimensions of each of these. What equation do we have? We have dimensions of X, that is the dimension of length, and we can find out from that only dimensions of each of these. Now let us see whether we can get or not. Are you getting? Based on morning's class, you can do it. Based on what I told you in the morning, you can do it. Okay, let me give you a hint. How many equations do we have in dimensions here? You may think that we have just one equation, but no, we don't have one equation. We have many equations here. Let me tell you the number of equations. There are many unknowns. How many unknowns do we have? A, B, C, D. But we can get each of these easily if you understand that we have many equations here. Number one, CA is being added to CB. So it has same dimension as that of CB sine D. That has same dimension. And this has same, this CA divided by e raised to power AB has same dimension as that of X. But e raised to power AB is dimensionless. It is dimensionless.
Yes, dimensionless.
And also I told you beginning in the morning also that A into B
But
itself
trigonometric ratio is also not.
A to into B itself also will be dimensionless. A into B also will be dimensionless because the argument is also dimensionless. Okay. A into B is dimensionless. And one more thing here now, that CA has dimensions of sine D is also dimensionless. Sorry.
Sine D is also
Sine D is dimensionless. L is 0. And argument of sine D, that is D, that is also dimensionless. Argument 0. I told you all the trigonometric ratios, all exponential terms and their arguments, these are dimensionless. This is the exponential term, total is dimensionless, and its argument AB is also dimensionless. Total sine D dimensionless, and its argument D is also dimensionless. So these are all dimensionless quantities. So already I got D to be dimensionless. But I don't know what is the dimension of AB. A into B is dimensionless. If A into B is dimensionless, and also CA has same dimensions as that of CB. Why CA has same dimension as that of CB? Actually, CA has same dimension as that of CB, but sine D is otherwise also dimensionless. So dimensions of CA is the same as that of CB. Dimension of C can cancel the dimension of C. Then I can say A and B are having same dimension. Both are having same dimension. So square of that dimension will be dimensionless. So it means individually A and B are also dimensionless. So A is also dimensionless, B is also finally dimensionless. Both are, because their product is dimensionless and both are having same dimensions. So overall each is equal to dimensionless quantity. So we got already A dimensionless, B dimensionless, D dimensionless. We are left with C. We now see this equation here. C into A has dimensions of X. This denominator term is dimensionless. Denominator dimensionless, numerator is C into A. A is dimensionless, and that is having dimension of X. X has dimensions of length. So then effectively C has dimensions of length because A was dimensionless. We are able to get or not?
Yes, sir.
This was a very simple equation because I just framed it now only. So, but maybe somebody can think of some complicated way of framing it, and they may end up framing a little more difficult question, and it would not matter. Our answer would not change if I give it plus minus here. Then also our answer would have been same, and our answer will also not change. Our answer will again not change if I give it as A by B. Then also our answer will be same. Are you understanding why?
And D also changes, also no change.
Then also we can say A upon B will be dimensionless. It means from here we are getting A and B are having same dimension. From here what we are getting? A and B are having same dimension. But what is the dimension individually? Now each is also equal dimension. By this we are getting each has equal dimension. And if A and B are having same dimension, then overall this denominator otherwise will also be satisfied. Okay, means we can do it.
If we change the angle also, no change, no sir.
We can ask in many. What angle?
Means sine D you kept, D.
Means in place of D, if it is not D, if it is X, Y, Z, etc., something like that you are saying, right?
Yes, sir.
X it cannot be. Why it cannot be X? Because it is having dimension, and inside it there cannot be a dimensional quantity. If X is there, only one possibility, then the person should say that maybe some quantity multiplied with it, that is making it dimensionless. Then only we can think that it is becoming dimensionless. Otherwise, I cannot take such terms like X. But when such questions are usually asked, in those questions, it is our common assumption, otherwise we cannot even solve it, that there are no additional dimensional constants here being multiplied. Because if such dimensional constants are there somewhere in between, then I cannot guarantee that what are the dimensions. I cannot say, for example, if hidden 1 is there, which is multiplying and which has dimensions of 1 meter per second, then so many things can happen. Then B may be having some dimensions. In that case, B will not be dimensionless. Then B will have dimension of opposite of this dimension of meter per second, in order to make the total dimension effectively equal to X. Means then so many things can happen. We can modify, but that assumption is there that whatever we are seeing here, these quantities are only having dimensions, and there is no dimensionless constant being multiplied. Okay.
Sir,
Yes.
when we take e power a by b will be dimensionless, right, sir?
If we have taken a by b, then whatever we take, if we take ac by b, or if we take e raised to power ad, whatever you are taking in this place, this term will be all dimensionless.
Sir,
We cannot take X, no, sir.
We cannot take X because X has dimensions. How can we take X?
Yes, sir.
We cannot take
Here,
X as dimension.
when we take a by b, AB will have same dimensions, no, sir?
Yes, definitely.
Then how CA is equals to CB, then what is the dimensions of C, sir?
If A and now also A and B are having same dimension, by this also we are getting same confusion. So where is it creating any trouble for us?
Sir, here when we take A as L, A dimension L also no problem, no, sir, then.
Oh, I got your point. I got your point. Yes. Means we cannot determine in that case, right?
Sir.
Then I think I will have two cases. Either, or then I can ask this question. Either C has dimensions of L, or A equal to B's dimension, and both are having dimensions of L. Or I can say one more thing then. C has dimensions of L root and A has dimensions of L root. Then many things can happen, I think so. Yes, you are correct. You got it right. Then we cannot tell. I thought we could tell in that case also, but no, in that case we cannot tell. If I put it as A by B, then I will have to give some additional information. Otherwise, we will not be able to predict the dimensions. But the question which I framed, in that we are able to predict exactly.
Sir, then instead of D, if you take C, then it will be no problem.
Instead of D, if we take
C, then we can say that C is dimension.
Then we can say. I have changed the question meanwhile to tell everything, but let us stick to the original question. What was the original question? Original question was this: CA plus CB sin D upon e raised to power AB. And for that original question which I framed, for that we already got this result, and that is correct only. Yes, I said that we can modify it in different ways, and by modifying we can again analyze it, and we can still get the answer. But I tried to modify it quickly, and I ended up modifying in a wrong way. I was not analyzing that properly, but you came up with a right reason, that if I just say A upon B, then I will not be able to predict. I will be able to say only A has dimensions of B, but I don't know what is the dimension of C and A. Total dimension, I can say C into A has dimension of X. But what part is of C, what is of A, that we are not able to predict in that case. And there can be so many other possibilities then, right? Then this may also happen that A and B may have dimensions of time. If I say A by B, it may be of time also. We don't know what it is. Then C into A will be L. Then C may become meter per second also. So then so many things can happen. Okay. Right. Next question. Next, not question. First of all, I can take the second point. One point I already told here. Second point I can take here. Second point is to derive relation between actually I should not call it derive. I should say to guess relation between physical quantities. Sometimes that too, sometimes, always we cannot make a guess also. Derivation means something which will always be true, which will be, means it is like a sort of a guesswork, which yes, we can get idea that it we are actually getting exact relation also, but this will not be, we are not able to tell the constants, what additional constant. For example, time period formula is 2 pi root of L by G. So can we get exactly 2 pi root of L by G by dimensional analysis? No, we cannot get. We cannot get the constant terms. Constant could be 2 pi root of L by G, or it could be 2 root L by G. We will not be able to predict. So morning there was one question which we were taking. Let us finish it now, and that was given in NCERT also. Or maybe one question is given in NCERT. I think I should take another example which is not given in NCERT. I should take some example like that. Let us say you don't know what is the formula for centrifugal force, although you know now. But let us say we have not done that chapter and you don't know what is the formula for centrifugal force, and we want to derive the formula for centrifugal force. Centrifugal force F depends on, let us say, mass and radius of the circle and velocity.
Yeah.
Then that is, centrifugal force is dependent on these three things, and I want to find out what is the relation between M, V, R, etc. and F. That, so let there be some relation. I don't know what that relation is. What do we want to find out? We want to derive. This is the question. Derive relation between centrifugal force and the other quantities like F, M, R, and V, or derive the relation for centrifugal, derive the formula for centrifugal force in terms of the other quantities. That is our question. Let us try to do that.
ML T4 minus 2.
No, we already know the relation. Obviously, you can do it, but no, the thing is, are you doing it correctly or not? Let me check once. How to do method we should know, because sometimes the relation may not be familiar to you. In fact, if they have asked such question, in fact, they should ask always with those relations with which you are not familiar. Then only it is helpful. Otherwise, what is the use if you already know the relation? So right now, I'm not able to think of some examples in which you don't know already. Otherwise, I could have asked such question maybe. Although time period formula you don't know right now, that we will derive later on in SHM chapter. But time period I'm not taking because that is already given in NCERT, so that I'm not taking for the time being. Derive relation between this centrifugal force and MVR. So let the centrifugal force be related like this. F is equal to some constant, maybe K. I don't know what that constant is, dimensionless constant, into M raised to power A into R raised to power B into V raised to power C. I will keep on naming these numbers A, B, C, D, etc. These terms. And then I will try to derive this. By how to derive? Just one very simple way. Both sides compare the dimensions. Dimension of left hand side equal to dimension of right hand side. How many questions do we get from there? We get 3 questions.
3 questions.
Can you open 3 questions?
Yes, sir.
One will be in power of M, one will be in power of length, one will be in power of time. 3 questions and 3 unknowns. A, B, C are 3 unknowns. So we can solve 3 equations easily and we can get the dimensions. Not a difficult task.
So BC will need to convert into time.
What?
We will need to convert it into time, sir. You told
not time. Not time, whatever dimension is. What do you mean by time? How can we convert velocity into time? Length into t to minus, that is its dimension. We have to write in that way only. R is length only. R also we have to write L. M is M only. M we have to write M. M raised to power A, L raised to power B, and at last V raised to power C. That, and K I am assuming dimensionless, so I'm not taking dimensions of K. And the left hand side is mass M kilogram meter per second square. Meter means length, per second square means T raised to power minus 2.
T4 minus 2.
Now just equate. What is the power of A in left hand side? What is the power of M in left hand side? Comparing the powers of M. Okay. Comparing powers of M in both sides. If in left hand side we have M, but in right side we don't have M, then what we should do? Then we will take the power that side in which side we are not having, that we will assume to be 0.
Yeah.
Understood? If in one side it is there, but other side it is not appearing, then we will assume that to be 0. But here both sides M is there, so 1 in left hand side and right hand side is A. A is equal to 1.
B equal to 2.
Similarly, B is coming out to be equal to 1 side and other side
Minus
plus
1,
C.
sir.
1, sir.
Left hand side 1 and right hand side B plus C. Second equation. Third equation, left hand side minus 2 and right hand side minus C.
C equal to 2.
So we are getting answer this way. Okay, leave it. Anyway, now what's the formula then? Formula becomes, let's put the values back. C is coming out to be 2 and then B will come out to be, B plus C is 1, B is coming out to be minus 1.
-1.
Then we are getting formula m raised to
Okay.
power a. M raised to power a means m raised to power a. B raised to power what? B raised to power C.
C.
B raised to power C. And C is minus 2.
C is 2, sir.
C is 2, sorry. C is 2. Then it, okay, then it becomes m into V square. You already know what it will become, although.
Sir,
M
what
into V
about
square,
K?
right? K is dimensionless, I told you already in the beginning only.
Yes, sir. When we take dimensionless F is equal to, we have to say that we have to prove that K is 1, sir.
That we don't know, but here luckily we got that only. Actually, formula is this. Actually, formula that we got is K into m squared by r, and K is
Yes, sir.
some dimensionless constant. But always the dimensionless constant may not be 1, and it is 2. That's why I said by the dimensional analysis, we cannot determine this dimensionless constant values. This is the limitation of it. We are able to derive the relation. Always relation also we cannot derive. In certain cases, we are able to derive relation. But in certain other cases, we cannot even derive relation also. And where we can derive relation as well, there also we have a problem that we cannot exactly get the value of dimensionless constants. Next, we have to convert one system of units into other system of units. This is derivation of relation. Another is to converge.
Third one, sir.
Convert system, one system of units to other system of units. Example we can take, for example, if work or energy I want to convert from CGS energy and force. These two examples I will take. Similarly, others also we can do. Energy I want to convert from MKS to CGS, MKS to CGS, or MKS in energy. MKS is also SI unit. SI to CGS I want to convert. In CGS, by the way, we call it as, name is given for that, dyne,
Erg.
DYNE.
I said
Sorry, that is for force.
erg.
That is for force, not for energy. For energy, it is erg. And in SI, we call that thing as, you already know, joule. And in case of force, if I want to convert from MKS to CGS, then in MKS, we call it as, MKS is SI again in force. You already know what is force unit in MKS, Newton. And in CGS, that will be called as dyne.
Dyne.
Let us convert now. Let us convert. How to convert? I will use this formula. N1U1 is equal to N2U2. N2 is the N1 is the numerical factor multiplied by the unit is equal to the numerical factor in the second unit, second system of units multiplied by the corresponding unit. So this will always help us to get the answer. So joule. How to write joule? Joule we will write as, what is the dimensional formula for energy?
kg. Dimension formula m L square T minus 2.
M L square T raised to power minus
2.
2. That is it. Let us consider it as M1 L1 T1, and the other side is M2 L2 square into T2 raised to power minus 2. So I want to convert, how many units of energy I want to convert into other unit. Maybe 1 joule I want to convert. I want to see 1 joule is equal to how many arcs? Let us say 1 joule is equal to n arcs. What do I want to find? I want to find out n value. That is what we mean by conversion. If I am able to find out n, then I got the value of that 1 joule is how many arcs. I am able to tell that. So what I want to do, I want to find out n. Means in our this equation n1 u1, when I am writing as n2 u2, in that equation, what is n1? N1 is 1 unit. What is n2? N2 is n units. I don't know what is n2, but n2 is n unit. Then what is n? N is coming out to be m1 L1 square into T1 raised to power minus 2 divided by m2 into L2 square into T2 raised to power minus 2. Now, what is m1 here? In one system of units. In MKS, m1 is in MKS kilogram kg. So that will come out to be 1 kilogram is equal to 1000 grams. Means I can say m1 is equal to 1000 times. m1 is equal to 1000 times of second mass unit, right? What about L1? We know 1 meter is equal to 100 centimeters. Then I can say L1 is equal to 100 times L2. What about time? Time T1 is also second and T2 is also second only. CGS and MKS both are same. Let us put these values here. Then what we get there from there. M1 is equal to 1000 times M2. So it will become 1000 times L2. 100 times L2 square into T1 minus 2 upon T1 is also T2 only. T2, everything is converted into M2, L2 and T2. T2 raised to power minus 2. Now divide these two. If I divide, units will get cancelled out, then numerical factor is coming out to be 10 raised to power 2, 3,
7.
7.
10 raised to power 7. So what was our starting equation? Starting equation was let 1 joule be equal to n arcs. Then how many 1 joule is equal to now? 1 joule is equal to 10 raised to power 7 arcs. Therefore, 1 joule is equal to 10 raised to power 7 arcs. This is how we do in paper if we want to do, but I recommend you to do not by taking the dimensions, but instead of that, take the units only. What is the unit? Kilogram meter per second square. I will directly do it here on itself. What is 1 kilogram equal to? 1 kilogram is equal to 1000 gram. What is 1 meter equal to? 1 meter is equal to 1000 meter square. It is, I think, meter square. 1000 centimeter, 1000 centimeter, and that's squared per second square. So that is equal to 1 kilogram meter per second. See, 1 joule. I start with 1 joule. 1 joule. 1 joule I will write as 1 kilogram meter per second square. That will become this. Then finally, I will take the numerical constant outside. That is 10 to the power 7 gram centimeter square per second square. After that, write it as 10 to the power 7 arc. So whatever we have done in this as a formality, this we don't need. We will do it this way. Means I will. This is the way to do it when we want to do some objective question only. But if you want to write it on paper, let us say it is your board examination and you want to do properly, then I think then this standard way will be better. This way, which you have done here, right? Then this way will be better. So now, this is a conversion of one. And here, this is very standard, simple example I am taking. Question may not be this. Try Newton to dyne. It will come out to be 1 Newton will be equal to 10 to the power 5 dyne. We can prove it. You do it yourself only. This I am leaving as a task for you to prove. It can be done easily. Newton will be written as kilogram meter per second square. You can see it clearly. In place of meter square, it is just meter only. So in meter, only 100 will come. Then 100 into 1000 will become 10 to the power 5. So we can quickly prove it. Now, if I ask in a different way, I say that in our new system of units, one length unit is equal to 3 meters. In our some new suppose system of units, and 1 kilograms, 1 meter mass unit is equal to, let us say, something, whatever, 5 kg. Means some other numbers which are not even like 10 multiples of 10 also. 5 kg. Let us say it is that. And similarly, time is, let us say, 1 minute is the unit in that. That is the time. And I want to find out in this what will be 1 joule. Can you still do that? I think we can do now, because length unit we know, mass unit we know, and this we know. So our standard, if I convert in terms of standard, what will be M1 coming out to be? M1 will be 5 times of M2. Let us say M2 is SI unit. Here L1 is equal to 3 times of meter is SI unit, 3 times of L2. Similarly, 1 minute. 1 minute will be our unit of time. Time 1 in 1 unit is equal to, in the second unit, multiplied by 1 minute is equal to 60 seconds into 60. 60 into T2. Then again, we start from the same way we will do it. This way only we will do it, the way we have done it here. But in this case now, in place of 1000 and 100 and in place of time, there was nothing. Now we have to put these new values which we are getting here, like 3, 5 and 60. And we will still be getting the answer.
Yes.
Okay.
Yes, sir.
Right. So next example, developing your own system of units. This is also one kind of that example only. In fact, what should I do? I think it is same only. This is like developing the new system of units. But when they say like this also, means okay. Let me say in this way: developing a new system of I don't know, should I call it system of units or system of fundamental quantities? But I mean to say both. I can develop a new system of units keeping the same fundamental quantities, or I can change the fundamental quantities and I can develop a new system of fundamental quantities. How to develop a new system of units? This is the example given above only. But let us change the fundamental quantities itself. For example, I can ask you a question like this. Let there be a new system of unit where the fundamental quantities are force. Let fundamental quantities be speed, force, and energy. Let there be new system of unit where these three are fundamental quantities: speed, force, and energy, and derive the dimensions of dimensional formula. Derive the dimensional formula of length, mass, and time in terms of these quantities. In terms of these, what are the dimensions of speed? Let the dimension of speed in that case be v. What is the dimension of force? Let the dimension of force be f. What is the dimension of energy? Let the dimension of energy be. What I want to do, I want to derive the relation of L in terms of something f raised to power a, e raised to power b, and v raised to power c. This is what we want to do. So I don't know what it will come out to be, but we will do the same way as we have done above also. Force will be, what is the force dimensional formula normally? M into
L into L into 2 minus 2.
raised to power a. Energy, M L square T raised to power minus 2 raised to power b.
Square T power minus 2.
Sorry, yes, right only, but not one more bracket.
L,
Next, velocity, L T raised to power minus
L
1.
T power minus 1.
See, this side is just L, remaining which are not there. I told you before, when it is not there, take it 0. Now compare the powers of, or powers we call as exponents. Compare the exponents of M, L, and T, both sides. How many questions and how many unknowns? 3 questions and 3 unknowns. Then we will be able to get the dimensions of length. Here in our new system of unit, what will be the length acting as? Length will be acting as a derived quantity. And what will be the fundamental quantity? The force and the velocity and the mass. These are the fundamental quantities, and we can do that. So the fundamental quantities are arbitrarily chosen. In the beginning, they are chosen. By convention, they are chosen. Means somebody chose that fundamental. Now, by now, we are just treating those only as fundamental. But if somebody would have started choosing these as fundamental, then these could also be equally fundamental quantities. So there is nothing more fundamental in length as compared to force. Both could be equally fundamental. Although length is more convenient to measure, we know that, and force is not that easy to measure. That is another issue. But theoretically, there is no problem, and we could have taken force also as fundamental quantity. Start now and find out the answer. How do we do it? Same way as we did the first case here, deriving the relation deriving relation. In this case, force is equal to K ma RB. That only we will do. 3 equations, 3 unknowns. One equation is A power of m is A here, power of m is B here, and nothing is in that side. So A
A
plus
plus
B
B
is
equal to
equal to 0.
0, sir. Yes.
Second one is power of L. Power of L is A
A plus
A
2B
plus
plus
2B
C
is equals to 1.
plus
1.
C is equal to
Minus 1.
1. Time is
Minus
minus
2A
2A
minus
minus
2B
2B
minus C
minus C is equal
equals
to
0.
0.
0.
So starting from 1 is simple. It will give us B is equal to minus A. So I will replace B. If I replace B, then second equation will give us A minus 2A plus C is equal to 1. And third equation will
A is
give
equal
us
to C.
minus 2A plus
Yes.
minus 2A plus A, 2A
Plus 2
minus C is equal to 0. C
minus
is
C
equal
is equal
to
to
0.
0.
C is equal to 0. And what is A?
A equal to minus 1.
A is equal to minus 1, sir.
A is equal to minus
1.
1. Then what is C?
C is 0.
C is
C
0.
equal to 1.
C 1, sir. B 1.
B is 1.
Yes, sir.
Yes, sir.
Yes, B will be 1. B is equal to 1. So we are getting this. B is 1. Then what is the equation coming out to be? Equation is coming out to be length is equal to F raised to power 0. No, F raised to power minus 1.
-1,
And energy raised to power
1,
1. And velocity raised to power
0.
0.
0.
That's the relation. Okay. That is the relation. This was very simple example. In order to find this relation, I would not need to do all, because I already know work done is equal to force into displacement. So I already know energy has dimensions of force into length. So length will have dimension of energy by F. So there is nothing new in this we are deriving. But sometimes it may not be that simple to tell in the beginning itself. So therefore I went through this way. But my purpose was not to tell this question in that way. This question, if I want to tell, I could do it orally also, and you could also do it orally, because in this we have a direct relation already between energy, force, and length. But sometimes we will not have such direct relation, and we may not be remembering it even if it is there. So in those cases, we will have to prove in the same way, the way I told you to prove here, right? So okay, with our dimensional analysis that we have done, now we can start with new topic, that is errors, accuracy, and precision, etc. All these things we will deal. What do we mean by something being accurate?
Approximate.
Is almost correct or near.
When we say length of a given thing is 1 meter, then and we are measuring it using a scale. If we are measuring it using a scale, and let us say in this scale there are 100 centimeters there in that scale, and then we are putting the length across it here like this, and this rod has length of 100 centimeter. So is it accurate?
Yes. Yes, sir.
Yes, sir. Accurate.
It may not be accurate actually. How do you know that the length that you are measuring is measured by a correct scale? Maybe the scale is not correct, maybe the scale is not accurate itself. Therefore, we cannot say it is accurate. Means it may have some error. First of all, the thing which is not accurate will have error. The thing which has 0 error is 100% accurate, and the thing which have large error will have less accuracy. Accuracy is opposite to error. More error, less accuracy. Precision is something else. That is a different thing, right? But errors and accuracy are opposite to each other.
Inversely proportional.
These are, we can say, means these are opposite to each other. Inversely proportional we cannot say, because these are not some physical quantities. Error is not a physical quantity. Accuracy is not a physical quantity, which I can say as inversely proportional to other or something. But yes, it is just means we can say one thing is more, other thing will be less. So error is something which we calculate for all the physical quantities, but it is not itself a physical quantity. Similarly, accuracy. How do we define error? I will define it, but right now, other things also I will tell you. Let us say somebody told you that this is very good scale and it has nothing is wrong in this. It is 100% accurate. Then also, how do you know it is 100% accurate? What do you mean by definition of being accurate? How do you know it is exactly 100 centimeter? What is the definition of 100 centimeter? You will be surprised to see that definition. 1 meter has definition of the distance traveled by light in 1 upon 2997992.458 seconds. That length is 1 meter. What length is 1 meter?
So seconds.
Distance when the light, the distance covered by the light in this 1 upon this seconds is equal to 1 meter. It is not equal to second. I'm not saying 1 meter equal to second. I'm just saying it is the distance covered in these many seconds.
Yes, sir.
Distance covered by light in vacuum also. In vacuum, distance covered by light in vacuum. By light in vacuum.
The distance equal to speed into this much time we need to.
In vacuum in 1 upon 2997992.458 seconds is equal to 1 meter. That is the definition of 1 meter. So see how strangely we are defining 1 meter. We are not defining it in any other way. In order to why this definition we consider as right, we can think in this way that we have said that speed of light is constant only. Speed of light always remains constant, and it will be same here and in any other place in this universe, and it will be not even dependent on the frame of reference. For example, Earth is moving with 30 kilometers per second, and somebody Sun is moving with I think 200 kilometers per second about the center of the galaxy of Earth. Sorry, about the center of this galaxy. What is the galaxy? Our galaxy name is Milky Way galaxy. About the center of Milky Way galaxy, Sun is also rotating with 200 kilometers per second nearly, and Earth is rotating around Sun with 30 kilometers per second nearly. Overall galaxy center, our galaxy center is moving towards Andromeda galaxy, and Andromeda is moving towards us. Are you there?
Yes, sir.
Yes, sir.
Okay. I thought you were calling me. Wait. Somebody else is there. Anyway. So yes, right. So I mean to say that this speed of light will be independent of the speed of the reference frames, and that is wonderful thing. Otherwise, if the speed of the reference frame changes, if the speed of the reference frame changes, and there is something which is still same in both the frames, in one frame and in the other frame, then I think it should be considered as a good way to measure the length. Okay, so whatever distance covers the light covers in that frame in 1 upon 2997992.458 seconds, that will be considered as the length of 1 meter. Okay, we define it in this way because that length we can agree with this length in if one person is in one place, other is another place moving with different speeds also. Then also they can agree with some standard unit which will be considered as independent of the place where we are measuring it and independent of the speed with which we are moving. Although there are other issues also. If we start moving within the time also does not remain constant, time changes, and the definition of second will also be changing. Anyway, leave it. I don't want to discuss in that detail, and it is not required also. So mainly errors. How to define errors? Let us come with it. How to define the errors? If any physical quantity A is there, and I want to measure it, let us say simple quantity. I will start with very simple example. Let us say I ask you to measure the time period of a pendulum. How will you measure the time period of a pendulum? You are having a stopwatch. You are conducting the experiment and you want to measure it. Length is. I'm not saying that you measure by using the formula 2 pi root of alpha. I'm saying you measure it by experiment, by conducting the experiment. What you will do, you will just release the bob here. It will go to the other side. it will return back. So when it returns back, then you will measure the time, what time it took
Yes,
for the
sir.
stopwatch.
That is time period of 1 hour.
That will be the time period. Now, should we do that? That is not a sensible way of measuring actually. That is bad way of measuring, bad way of measuring, not a good way of measuring the time.
Error will be, sir, definitely.
Why is it not a good way? What is the problem in that? The reason is this. That I think I need to maybe show you something. Maybe.
Air resistance, sir.
What?
Air resistance.
No, not air resistance. Yeah, yes, those things are also there. But other than that, there is one more problem here. Let us say I have a stopwatch in my hand, and you are my friend here. My friend is standing here, and I am saying that you hold this bob, and I am here, and I have a stopwatch in my hand. I will say I will press this stopwatch, and then it will start running. And when I press it, at that time you release it. Now, the moment I press it, at that moment only this person will release, or there will be maybe some difference because
Some gap, yes, sir.
once he see I have pressed, and then he will release it. There will be minor time difference, even if time difference is very small, but there may be some time difference. And when it goes and returns back again, when it returns back, I have to again I have to stop it. So during stopping, I will be committing some error, and during releasing also, I will be committing some error, and that error may be significant. Maybe I have this error is, let us say I'm very fast. Even if I'm very fast, I'm committing error, let us say of 0.1 second only. Then 0.1 second in one time and 0.1 second again. Overall error may become 0.2 second error. If it becomes 0.2 second error, already let us say time period is just 1 second. And I
minus 0.2 that we need to do, sir.
And it's not a small error. It is 20% error. It becomes a big error, huge error. Yes, but I have a way to do it more appropriately. What I will do, I will do the same thing again. I will say, some of you may think that why I will ask another person, why should I not myself only do it? Even if I do it myself also, how will I be making it sure that when I will start the stopwatch, at that time only I will release the bob? Then also I may have some difference in timings. It may not be exactly same time. Anyway, there is another issue also. No, sorry, this issue can be resolved easily. First of all, let me resolve this. It can be resolved easily. What I will do, I will just let it go there and it will come back, and then I will wait for multiple time periods. When already nearly 30, 20 or maybe 100 time periods will be lapsing. After that only I will stop it. When that happens, if I wait for 100 time periods, then in 100 time periods, I will be getting 0.2 second error. First I got
that is not significant, sir.
But in 100 time period, how many seconds have elapsed already? Nearly 100 seconds.
100 seconds.
Let us say this time period was of 1 second approximately. If it is of 1 second, then how many time period, total time taken is 100 seconds. Out of that, what error now committed? 0.2 second. Then the percentage error means the error which I have committed here divided by the total value of time into 100. That percentage now will become just 0.2%.
0.2%.
So relatively, error committed in the value becomes so less, and my value will become much closer to the true value. Okay, I think enough of this. So understand, when we are trying to find out the errors, then we are conducting some experiments. So from the experiment, we are finding out the values. It is not like some theoretically some things are given and from that only we are getting the value. We are conducting experiments, and while we are conducting the experiment, then we may commit errors. So we have to look for the sources of error possible. One of these, I am giving you one example. There are several other things also. Random errors, like maybe some air resistance is there, that is having some error. Other possibilities are there. Time period formula is 2 pi root of L by G. I want to verify this time period formula, but I want to verify, then in my verification, what value of G I should put. Now value of G from place to place will vary. Will it be same? Or let us say rather than finding out time period, I want to measure the value of G using this. I can do this thing. T square upon 4 pi square is equal to L by G, or G will become equal to L upon
4 pi square L by G.
L upon T square into 4 pi square, right?
Yes,
that it is. So let us say I measure the time period and the length, and pi we know, 4 we know, we can find out the value of G. But again, how much error we are committing in time, that error will be transmitted to error in G also. What error we are committing in length measurement, because some error we may have committed in the length measurement, that error will also get transmitted to G also. So value of G will be not accurate because of two errors committed, one error in measurement of length, another error in measurement of time. we don't commit error by choice. Now you may think, why are we committing errors? We are not committing by choice. I want to measure the length most accurately. Even though I want to measure it most accurately, most precisely, then also I have a limitation because my scale gives me the reading up to centimeters. Let us say I'm using let us say it is 99 centimeter scale. Sorry, it is meter scale, but in that I measure the length to be 99 centimeters. If I measure the length to be 99 centimeter, how do I tell that it is 99.1 centimeter or it is 98.9? Maybe it looks like 99, but it is not exactly 99. Maybe it is 99.2.
Then point one we are committing error.
If it is more than 99.5, if it is more than 99.5, then I think I can tell. Then I will not call it 99. Then I probably call it 1 meters. But if it is something between 99.0 to 99.5, then I think I will be just telling it 99 only. I will not be able to say that it is what else. In fact, if it is somewhere from 98.5 to 99.5, I may end up calling it just 99 only. I mean, I have no other way to say. I cannot say exactly. I cannot say it is 99, 99.1. I cannot make such. So therefore, the scale itself, which we are using, that also decides that the length we are measuring is more accurate or not. I can have some better sophisticated techniques to measure, by which we are able to measure the length, not up to centimeters, but up to millimeters. I can have millimeter scale. Then I can predict in a better way. I can have a scale in which I can measure up to less than millimeter. I can measure up to 0.1 millimeter. Then the error will keep on becoming less and less. The value will keep on becoming more and more precise. When we are able to measure less values in the scale using the scale, then we say our value is more
accurate, sir.
No. You listen, just listen and precise. This is the word. Then we'll say our value is more precise. When we say our value is more precise, if the scale with which we are measuring, if that scale is capable of measuring lesser values, then the more precision is there. More precise we are able to say the value we are measuring. Accuracy we can still not say. Accuracy will depend on other factors also, but it is more precise. The word is precise for that, right? Okay, anyway. So right now I think I should maybe formally start telling you how to write down, then you will. Okay, let us write few things. Number 1, mean value of measurement. Mean value is also called as true value. If I have a quantity A, and I am measuring it n number of times, each time while I am measuring it, I end up measuring it as A1, A2, A3. Then I will say sigma AI divided by how many times I am measuring this quantity, n times, divided by n. That will be the mean value of the measurement. This mean value of the measurement I will call as true value. Some of you may think that I am foolish, I am measuring large number of times. Why not you do it once only? But we have to do that. Reason is, for example, let us consider the case of measuring time period only. I conducted this experiment and I measured it once. And I conducted this experiment in the morning, in the evening, in the afternoon, or in the same day, in the same place only, but I conducted it in 3-4 times. Sometimes maybe by changing the location slightly, sometimes by not changing the location, but without changing the location in the same place also, again and again we are doing it. So what may happen sometimes there may be little air blowing in this direction. Sometimes there may be little air blowing in that direction, which may cause there may be some effect because of that. But if we conduct the same experiment over and over again and again, then some random errors, which we don't know what are causing those errors, the effect of those random errors will get reduced, and our value will start becoming more and more close to the true value or accurate value. True value only we will call as our mean value or the accurate value. Okay, we don't know what is the accurate value. Nobody knows. But depending upon the best we can do, in that is the best we can do. We can reduce the random errors in that. What is meaning of random error? Again, I'm using some word here, random errors. In fact, I think I could have taken types of errors also, but I think no, I will be telling you the things in between. There will be some terms popping up and I will be explaining you there only. Random errors, the errors for which the sources is not known. Are you there?
For which the reasons are not there, sir.
For which the reasons are not known. The errors for which the reasons are known, unknown reasons.
Like
Unknown
error is
reasons.
coming and we don't know why it is.
And error is coming, and it is sometimes this error will give us value little more than the actual value, sometimes it will give us little less than the actual value. So overall, when we keep on conducting this experiment large number of times, then we will not know. Wait a second. Just I think this call is important for me. Just wait a second. I will get back to you.
Yes, so
Wait a second. So random errors are the errors for which the source of error are not known to us, right? So and there are some systematic errors for which the sources are known. Two kinds of errors we can define: random errors, sources are not known; systematic errors for which the sources are known to us. For example, there may be some error in. There are some errors called as zero error. One is zero error, which is not a random error. It is systematic error because we know that its source. What is the reason for that error? Systematic error. Okay. Random error. How can we reduce the random errors? These can be reduced by taking large number of measurements. Can be reduced by taking large number
Average of them.
of and then taking average of those large number of measurements. That is a way to reduce this. Systematic error, we can reduce the one is zero error, one is systematic error is zero error, another systematic error is least count error. Least count error. These are systematic errors. We can reduce this. Least count error depends on the least count of the instrument. What is least count of the instrument? Least count, as the name suggests itself. I think from name you can get idea. Least count of instrument.
Where do we get less error?
The least count of instrument means the least we can measure by an instrument. It is the least value that we can measure using an instrument. The least value that we can measure using an instrument. The least value that we can measure using an instrument is called as least count error.
What's tell any example on this?
Sir, didn't
Example is if I have a meter scale in which the least division is up to centimeters, then the least count will be centimeters.
That one is before precise meters.
If the meter scale is of millimeter scale, if it is based on millimeters, then the least we can measure is millimeter. Then millimeter will be the least count will be millimeter, and the least count error will also be millimeter only. Least count error is also that. The least count error is nothing but the least which we can measure using an instrument. That is called as least count error. So sometimes we can measure the least minimum possible up to 1 millimeters. There are certain devices which we will be studying now, vernier calipers and screw gauge, by which we can measure into up to 0.1 millimeter we can measure using vernier caliper, and 0.01 millimeter we can measure using screw gauge. These are the least counts, and these are also the least count errors.
So then what does precise mean, sir, exactly?
What
does precise mean?
Precise, I am coming first to see what is least count meaning. Forget precise. Right now I'm discussing least count and you are going to precise. Why are you worried about that?
Before you said that, no, sir. When you are talking about that meaning.
I have not yet written it formally. I will tell it. Okay, I said some words, but I will explain. Don't worry. First, you understand least count. Have you understood least count or not?
Yes, I understood.
Now
Yes,
you
sir,
write,
understood, sir.
write precision if you want to write. We can write precision now only. Precision versus accuracy. Just write down. Lesser the least count. Lesser the least count, better is the precision. Better is the precision. Lesser the least count, better is the precision. And next you write lesser the least count, better is the precision. And second thing you write is lesser the error, better is the accuracy. Better is the accuracy. These two are quantities. If the precision is better, then chances of accuracy is also improving but it does not mean if it is more precise instrument we are taking, then the result will be more accurate only. Sometimes there may be some other sources of error also, which may be there. For example, I am using a very good instrument to measure the length. I'm using very good instrument to measure the length, and I want to find out the time period formula. I want to verify this 2 pi root of L by G. But length I measured very accurately, but I committed some other errors. Maybe, for example, this length I measured much accurately, let us say, by using some scale. But I forgot to consider that the temperature has increased. So as a result, the scale, which was of 1 meter length, and I'm thinking it is to be 1 meter length, but because it is expanding, and it is expanding, then although it is measuring length, and I'm thinking it is measuring more accurately up to millimeters, but it is not able to measure up to millimeters correctly also because of change of temperature. So sometimes other factors may also crop in, and as a result, because of those other factors, the accuracy may still suffer. So, but yes, there are better chances will be there, obviously, if there is better precision. So precision is somehow related to accuracy. More precise, then more accuracy can be there, but always it will be there is not necessarily true, right? So these are two different things. But this is one thing only. Lesser the least count, better is the precision. Always true only. We say like that only. If least count is small, then the precision is more. So which instrument has a better precision? Vernier caliper is able to measure up to 0.1 millimeter, and screw gauge is able to measure up to 0.01 millimeter. So which has better precision? Vernier caliper has better precision, or screw gauge? Screw gauge has better precision. Lesser least count, more precision. So screw gauge has better precision than vernier caliper. Which has more precision? Screw gauge than vernier caliper. And vernier caliper has better precision than normal millimeter scale. Vernier caliper has better precision than that, right?
Yes.
Understood now? Similarly, stopwatch. If normal watch, if you are having the watch in which we measure the time by this way, normal second hand clock is there in which second hand is running. In that we are able to measure up to 1 second. But if stopwatch, we can measure up to 0.1 second also. Sometimes better than that. Sometimes 0.01 second also. Some stopwatches are like that. So stopwatches also have better precision as compared to the normal regular watch which you wear in your hand, right? With the second hand clock, which second hand will keep moving in that, right? And in that, circular dial based clock. That clock. So in that clock, there will be least count will be 1 second, but the stopwatch may have least count. The digital clocks, the stopwatch, they may have least count better than that. So their precision will be more. So you understood precision versus accuracy?
Understood.
Precision is only and only related to, it is only and
Least
only
count,
related
sir, only least count.
and it is only and only related to it is just related to instrument only. It is like least count, it is just related to instrument only. I can say precision is of instrument, and accuracy is not of instrument only. Accuracy is of person who is measuring, how he is measuring, he is considering all the factors to be correct or not. He is taking care. He is taking care in performing the experiment. All the things he is considering properly. Random errors are less. He is taking large number of measurements. So many factors will be there, right? Zero error. Zero error is also something which we know in the beginning only, and we can do something to correct it. What we do to correct the least count error? Only thing I can do is I can change the instrument, and I can use a better instrument. I will not be able to correct it, but I will be able to reduce it. I should say, not able to correct, but able to reduce. What should I do to reduce the zero error, or to correct the zero error? We can correct also. How can we correct the zero error? What does it mean? First of all, it means something like this. Let us say you have a clock which gives us time correctly only, but your clock is not properly matched with the standard time. Standard time is 12 o'clock, but in your clock it is 1 o'clock at that time. It does not mean your clock is wrong. Only thing is it is not matched properly with other clocks. Okay. So what you will do? Will you be able to measure the time? Yes, you will be able to measure any time interval properly only. But if somebody is asking you what is time now, and you are saying it is 2 p.m. Actually, time is not 2 p.m. It will be, because it is already missing one more. It will be 1 p.m. See, now only you did the correction. How did you do the correction? By subtracting the zero error. So what was the zero error? Zero error is something which the instrument measures when it should give us zero value. It is measured value of instrument. Measured value of instrument when it should give us zero value. When it should give us zero value. Zero value means, for example, when the time gives us zero value. Time gives us zero value, 0 noon, we have this way that in the midnight, when 12 will be there, we will call it as 0, right? So when the time should give us 0, at that time the clock is giving us, let us say, 1 unit time. If it is giving us 1 unit time at that time, then that is our 0 error. Then how to get the accurate value in that clock always?
Minus 0 error.
We will keep on subtracting 1 unit from that, the time measured, then it will be giving us exact value. Same way, let us consider another example. Another example, if I have a speedometer in the bike, and in this 0, 10, 20, 30, 40, 50, 60, something like that is here. And let us say, you notice that the bike has not started yet, but already this needle was in this direction, pointing in somewhere along 10 unit. What does it mean? It means it is measuring 10 when it should measure 0. So that is the 0 error. What is the 0 error then? 0 error is if it is 10 kilometers per hour, then our 0 error will become 10 kilometer per hour. Why it is 10 kilometer per hour?
Because 10 minus 0 is
10 minus.
It is giving us value 10 when it should give us 0. So that is how we define always 0 error. What is it? It is the value which we get from the instrument when it should actually give us 0. That we call as 0 error. Okay. In vernier caliper also, when we do it, then also we will, another example I can take with normal scale. Let us say I have a scale here, a broken scale. It was broken from this side and I did not notice. And I ended up measuring the value and I got the length of the rod to be 20 units, 20 centimeter. But then I found that it starts from 5 centimeter. Again, what is a 0 error? Where it should give me 0, in place of 0, it is giving me 5 units.
and 5, sir.
Then that is a 0 error. How to correct it? How to correct the
We have to
0?
subtract from that value 20.
That we call as 0 correction. So 0 correction is equal to negative of 0 error. So how to make the correction? We make the correction by subtracting. So there is a way to just call it. We say that 0 correction is negative of the 0 error. That is how we subtract
Yes,
it.
sir.
So is it okay? Is it understood? 0 correction is
Understood.
negative. 0 correction is just negative of the 0 error. That is just negative of the 0 error. So what will be the value measured then? Then the value measured will become that value
Minus 5.
minus 5. Yes, it will be that. Okay. So negative of the 0 error we have to. So how to get the true value? We can say true value is equal to measured value
Minus
0
0
error.
error.
Or it is equal to measured value plus 0 correction. Because 0 correction is equal to negative of 0 error. So true value is equal to measured value. True value is equal to measured value minus 0 error, or it is also equal to plus 0 correction. Because 0 correction itself is negative of 0 error. Can the 0 error be negative? Yes, 0 error can be negative. Let us go to the example of bike again. If I go to the example of bike, and this 0, 10 starts here, 10, 20, 30, but the needle was already pointing towards something before that. Now, where it is exactly, if they have marked here also, let us say minus 10, then it means it is giving us minus 10 when it should really give us 0. Then it is again a 0 error. It is again minus 10, 0 error this time. Then when the bike will be running with 20 speed, actually the
And
speed will
only
not
it
be
should
20.
10,
And the
sir.
speed will be actually 30 units. Okay, so here we have to, but always we will do one thing only. Don't say now we will be adding 0 error. No, that will be subtracting, but here 0 error itself is negative. So when we subtract the negative, it will automatically become positive.
Yes, sir.
So measured value 20, 0 error minus 10. So what is the 20 minus of minus 10? That is giving us 30. Understood?
Yes, sir.
Right. So this is how we do it. Let us come back to our mean value. Mean value. Here I'm calling mean value as true value, but okay, let us just call it as mean value only. This will confuse otherwise with this true value. True value will come out to be this measured value is the mean value actually. The measured value itself is the mean value. If I do it large number of times, certain experiments we don't do large number of times. We do once only. If we do once, then it is just that measured value. But certain experiments we can do large number of times, and then when we do large number of times, then we take the mean of those values. Length, no need to measure the same length again and again. Every time we will end up measuring it same only. But there are certain things which we will measure different times and it may give us slightly different results. Certain experiments are like that also. In those cases, because there are some random errors for which we don't know the sources. And to reduce those random errors, I have to take not one measurement, but large number of measurements. And when we do that, then the mean value taken after large number of measurements will be regarded as this value. And that value minus 0 error will be becoming the true value. Anyway, is error, let me define normally. These are two systematic errors, but other errors like, how do we define error? Let me tell that thing also. error measured in one quantity. Error of measurement. Error of measurement. That will be this thing. Let us say I measured the quantity A and it came out to be I in the ith measurement. Measured value in ith. Measured value in ith measurement. That is AI. So what is the true value? I already defined the true value. True value is nothing but the mean value. That is true value also. Actually, that is another thing. I think this is also correct here. What I'm saying, true value after zero correction when we do. But in order, if we are talking about the random errors, just wait a second. Hello. Students, I think I will not be able to take class now because I have to leave. I'm on journey, I told you, no. But I was thinking that whatever best I can do, I took these 2 classes also. Otherwise, I was not having time. I'm doing some work also, and I'm moving from one place to the other place. So, but meanwhile, I thought maybe
We read NCERT,
Okay,
no
sir.
problem.
now you read from NCERT, and remaining part
Okay, sir.
I will take tomorrow. Okay.
Okay,
Okay,
sir.
thank you, sir.
Thank you,
thank
sir.
you.
Okay, sir. Thank
Bye,
you, sir.
sir.
Bye,
Thank
sir.
you, sir.
Thank you.
Thank you, sir.
Thank you, sir. Bye,
Sir,
sir.
where are you going, sir?
I am going to my native place actually, and that is far away from Delhi in Himachal. So I'm going to that place. So meanwhile, because it is locked down, so I'm not getting the conveyance properly. So sometimes I'm staying also in hotel. Now again, I have to start my journey again. Okay.
Okay, sir.
Okay, sir.
Thank you,
Okay.
sir. Bye, sir.
Bye, sir.
Thank you, sir. Bye.